Hi Pre-Calc, we're back. We're going to graph this one. So like I mentioned before, you want, if we're secant or cosecant, you actually want to replace it with its reciprocal. So if this is secant, then its reciprocal is cosine 4x plus 2. You don't want to do anything else but replace it with its reciprocal. So I'm actually going to graph this before I graph this. I'm just going to write down the standard table for the cosine. All right, and now I'm going to work on doing the new table for this new function. So this will be the new table over here. I'm going to go through all the work that you've seen me do before. So the first thing I'm going to do is calculate the period. For the cosine function, it's 2 pi over b. b in this case is 4. So it's 2 pi over 4 or pi over 2. That is the width of this function. It's really skinny. The increment is the period over 4. So now I'm going to do 2 pi over 2 divided by 4. I'm going to write that out the long way because it's a little bit easier for some people if I do that. So pi over 2 divided by 4 is the same thing as saying pi over 2 times 1 over 4, which is the same thing as saying pi over 8. So the jumps are pi over 8. You do not need to do the start and stop because the cosine function doesn't have a c value in it. So it's not pushed left or right. It's going to start at 0. So I'm going to now make the table because the only thing in this function, the only thing inside or affecting the domain is the 4x. This value and this value is affecting the range. So I'm going to finish up over here with this one. So 0, then I have to add pi over 8, then I have to add pi over 8 again. Pi over 8 plus pi over 8 is 2 pi over 8, which would then be reduced to pi over 4, then 3 pi over 8, then 4 pi over 8, which reduces to pi over 2. Good, and that's the width of the function. So I just kept adding the increment of pi over 8 to get the next values. So whatever comes out of the cosine function, is going to be multiplied by -2 and added to 2. So what's happening is the output values are shifted up 2 units, the amplitude is pulled up 2, down 2, and the graph is being reflected over the x-axis. So it's a lot of stuff. So here we go. Y is going to equal to -2 times the output of the cosine value plus 2. So the first value is going to be -2 plus 2, which is going to be 0. Next y value. -2 times the output of the cosine, which is 0, plus 2, that is going to be 2. Y is equal to -2 times the output of the cosine, which is -1, plus 2. So that's actually 2 plus 2. That's going to be 4. Okay, y equals to -2 times the output value plus 2. That's going to be 2. Y equals to -2 times the output value plus 2 is going to be 0. Okay, so that right there is me graphing the cosine function. So let's put that up. Let me just see how I want to scale this. Okay, I'll make these sort of tiny. Pi over 8, pi over 4, 3 pi over 8. I don't know where you guys are today, but man, is it windy here. Woo! Okay, pi over 8, that's going to be at 3 over 8. That's less than a half. That's less than a half, which means true of that is approximately a 1, 2, 3, 4. Oh boy. I might have to attach a piece of paper to this guy. Okay. All right, let's put these points down. 0, pi over 8, 2, pi over 4, 4, 3 pi over 8, 2, pi over 2, 0. Okay, so like again, we said there's a lot of stuff going on here. It's pushed up 2, it's reflected, and its amplitude is 2. And it's horizontally squeezed. All right, let me draw this guy. All right, there is one cycle of this graph. Let's just stretch this guy out. So we have more to work with. Okay, so at the bottom here, so then I got to go to the middle. I'm just going to repeat the pattern. Then I got to go up. Then I got to go to the middle. Then I got to go back down. Then I got to go back to the middle. All right. I just feel like doing a little bit over here too. Okay, that one's down, so the next one's got to be in the middle. Next one's got to be up. Next one's got to be in the middle. Okay. Whew. All right. That is that. So the one in the black is the y equals -2 cosine 4x plus 2. And if you are with me, you are doing awesome, because this really is, this is almost as hard as they get. This is only missing a C value. I mean, this problem is something. All right, so now through all the center points is where so now if we draw the secant, through all the center points where the cosine is at the center, the secant will be undefined. So through all the center points is actually the vertical asymptote. You're trying to make the secant undefined, not the whole problem equal to 0. Wow, I don't know if you guys can hear the wind. It is something. Alright, so if you remember, I told you that it's going to connect at all the hills and valleys. Okay, so it's going to connect at all the hills and valleys. So it's going to connect here, and it's going to go up. It's going to connect here, and it's going to go up. Connect here, it's going to go up. And all the valleys, it's going to connect here, it's going to go down. It's going to connect here, it's going to go down. Here. So use the asymptotes as a guide. Alright, so now if I took away, and again, one up and one down is one cycle, but the idea is if I took this guide away, this original line, I just used it to help draw. I just want you to understand that it's not both these graphs. That first graph was just used as a tool to help me figure out where are these floating parabolas in space? And how wide are they? Are they narrow? Are they very wide, right? So the actual secant function, let me write it down. Ooh, that whiteout is potent. secant 4x plus 2. So the secant function is actually these just floating graphs in space. The cosine function was just used as a guide. Okay gang, I'm going to end the video here. I'm going to put up your homework, and that's it for this week. Just keep working on those problems, and I will try to get to answer questions as much as I can. It's just these videos, you wouldn't believe how long they take to make. Okay, I'm wishing you a super lovely weekend, and I will catch you again for more lecture next week. Bye-bye.